Good day, my name is Ochada Matu. In this video, I'll be making a presentation on the peer review grade aided assignment course project on machine learning foundation for project managers offered by the Duke University on Coursera. In this project, we were given a model to predict the electric energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generator to generate power. We have a set of 9,568 hourly average ambient environmental readings from sensors at the power plant, which we will use the model use in our model. The columns in the data set consist of hourly average ambient variables as shown below. We have temperature, T, ambient pressure, AP, relative humidity, RH, exhaust vacuum, V, net hourly electrical energy output, PE, with the range as shown in this video. The review criteria the peer review will be graded based on four criteria. One, model approach. You want to see whether if the model is correctly modeled, like identify the type of modeling tasks, features to use, and possible algorithm to use. Model building. Did you compare at least two different models, different algorithms, different combination of features, or different hyperparameter combination using a validation set or cross validation to optimize your model? Then model evaluation. Did you use a set of reasonable evaluation metrics to determine the performance of your model and then calculate it on a test set? Then model interpretation. Did the model correctly interpret or communicate the performance? Now let's go straight to the solution. I have done this in the problem statement, which is the model building. In the model building problem statement, we have model specification. As shown below, in a functional relation, this model can be written as PE being a function of ATV, AP, and R. In the model in a model form or econometric form, it is stated below as PE being a function of beta naught plus beta 1 AT plus beta 2 V plus beta 3AP plus beta for RH plus U, which is the error term, where PE is the net hourly electrical energy output, PE, BO constant, B1 to B4, they are the parameter of the respective variables which we intend to model. In terms of the features of the variables, which is the 9,568 variables, the basic observation from the features after using simple Excel calculations like descriptive statistics and correlation analysis is the five variables are continuous variables. Temperature T has a strong negative relations with output variable PE. Ambient pressure AP has a strong positive correlation with output variable PE. Relative humidity has a weak positive correlation with output variable PE, and then exhaust vacuum has a strong negative correlation with output PE. There is no hyperparameter variables. In this is the descriptive statistic from the mean value to the standard deviation to the mode and also to skewness. Of course, from this variable, for example, like the skewness, you can see that all the whole variable exhibit continuous variable correlation. In the correlation table below, you can see that V has 0.869, AP positive 51, 51%, RH 0.38%, and then 8C, which is the atmospheric temperature, has 0.94%. This is good, and we can go ahead to do the model building. This assessment will use in terms of model approach. In terms of model approach, this assessment will use multivariate regression as the algorithm, although there are other algorithms such as logistic regression, decision trees analysis, and random forest, which can be used in carrying out this analysis. However, for the sake of simplicity, this assessment will only limit it to multivariate linear regression to predict the outcome. We have a set of 95 A6 hourly average ambient environmental readings from the sensors, that is the total observation. The data will be split into train. The train is splitted into 80%. That is, when you do the 80% of 9568, you will have a value of 7,655, and 20% for the test you have 1955. Alternatively, we can use the same algorithm, but I choose to drop PE with the least absolute correlation with output variable for the P for the second approach. In the regression analysis that I have worked on, of course, from the first output that we have run using the test variables, we have the R square having 0.93%, and for the coefficient we have negative 80. Atmospheric has a negative impact on the uh, output PE and V also, um, and the relative humidity. From the analysis itself, you can see that the least variable, which is the negative RH, relative humidity, has a negative minus 0.16. So for the second approach, for consistency sake, I use the same data for the 80% this approach for both the approach 1 and approach 2. So I dropped from this because this is the list, RH is the list. I drop it and then rerun it on Excel. The result shows the R square for the result shows 0.916, and of course you can see it from this figure. 80 has a negative influence on output, V has a negative influence on output. That is a 1% change in the value of atmospheric favor while holding other independent variable V and AP constant will result to a negative decline in the output PE, same as the other above. And in the model specification for approach 2 PE, of course you can see I've dropped the variable, and then this is the model specification. Being a function of this, RH is no longer in the model approach for the model specification 2. Now, model evaluation output matrix is for the model evaluation output matrices. You can see, then you can see what I've done: root mean square, mean absolute, MAP, and R square. Model interpretation for the output metrics. If you compare to this, approach 1 is better. The first approach 1 is better than the second approach. This is the end